An engineer walks past a wartime radar machine with a chocolate bar in his pocket. Minutes later, the chocolate has melted into a warm, gooey mess. But the machine itself is cold. Most of us would blame the heat, curse the chocolate company, and move on. This one man didn't. He asked one question that changed every kitchen on earth. It ended up transforming how the entire planet cooks food. This is the accidental story of how war technology, a melted snack, and a curious mind gave birth to the microwave oven. The microwave is one of those inventions we treat as background noise. Hit a button, food is ready. No flame, no heating coil, no waiting. But the microwave oven didn't just speed up cooking. It reshaped kitchens, eating habits, work culture, packaged food, and the whole idea of convenience. Right now, there are more than 1 billion microwave ovens quietly humming in our homes, offices, tiny rented apartments, and hostel rooms around the world. Reheat leftovers? 1 minute. Save cold coffee? 30 seconds. Emergency dinner? Open frozen packet? Beep, done. But did you know that this everyday convenience was never meant for kitchens? It began in a war lab designed to detect enemy aircraft, not reheat samosas. So, how did a secret military technology, a curious engineer, and a lab accident give you this noisy little box in the corner of your kitchen? Come, let's find out. The story starts in the 1940s. The world is busy blowing itself up, and the United States is pouring money into radar research. Radar is basically radio waves bouncing off objects to detect them. Nothing glamorous here for the average citizen. Just big machines, glowing tubes, and engineers tinkering with magnetrons. One key invention during that time was the cavity magnetron, a special vacuum tube that could generate powerful microwave radiation for radar sets. Microwaves, that word existed long before the oven, but nobody thought of microwaves as kitchen friendly. They were tools of war. But science is often a matter of bumping into the right thing at the wrong time. Microwaves are just one part of the electromagnetic spectrum, just like radio waves and visible light, but with a different wavelength. With magnetrons, engineers could make these waves strong and focused enough to detect distant aircraft in bad weather or at night, giving a huge military advantage. And in one of those radar labs, a self-taught engineer was about to notice something very odd. The hero of our story is Percy Spencer. Percy Spencer wasn't a typical scientist. He grew up poor on a farm in Maine, left school early, and taught himself mathematics and electronics by reading manuals and experimenting on his own. He learned physics by literally reading textbooks while standing guard at a mill. During the war, he became one of the world's leading experts on magnetrons. He was at that time working at Raytheon, the company building radar equipment for the US military. One day in 1945, Spencer was standing near an active magnetron. In the middle of his work, he noticed something very strange. The chocolate bar in his shirt pocket had melted. The room wasn't hot. The machine itself wasn't glowing like an oven. Yet, the chocolate had turned into a gooey mess. Most people would curse, clean their shirt, and move on. Spencer did not. His mind went straight into curiosity mode. Why did this chocolate melt? What did the magnetron do? This is the scientific method at its finest. Observation? Experiment. To test his suspicion, Spencer placed some popcorn kernels near the magnetron. Soon, they started popping and bouncing all over the lab. It was the first microwave popcorn before microwaves even existed as kitchen appliances. Fun fact, the world's first microwave popcorn happened inside a radar lab, not a movie theater. Next, he tried an egg. In one version of the story, a colleague leaned close to see what would happen. The egg heated so fast that it exploded on his face. Whether the details are exaggerated or not, the message was clear. These waves were incredibly good at heating food from the inside. Spencer realized he wasn't dealing with a weird lab accident. He had discovered a completely new way to cook. Percy told his bosses at Raytheon that this could become a cooking device. At first, they weren't excited. Engineers rarely are when someone tells them their military machine should enter the kitchen. Spencer then did something brilliantly simple. He built a metal box and fed microwave energy into it using the magnetron. The metal walls trapped the waves inside, bouncing them around and forcing them into whatever food sat in the box. The food heated quickly, while the box itself didn't need to glow red or have an open flame. And once they saw the potential, Raytheon went all in. The first microwave oven, which was called Radarange, was built in 1947, and it was ridiculous. It was 6 feet tall, weighed over 300 kilograms, and cost the modern equivalent of thousands of dollars. Restaurants and ships used them, but nobody had one at home unless they were the Sultan of Brunei. For almost 2 decades, microwave ovens were huge, expensive machines used in places where speed mattered more than cost. They were powerful, but people were also nervous about radiation cooking their food, and they thought it might mutate their children. Later, companies developed small magnetrons and better safety features. By the mid-1960s and 70s, countertop models appeared, roughly the size we know today. Prices dropped, fear slowly faded, and by the late 20th century, microwaves had become one of the most common appliances in homes around the world. The machine that was developed to detect enemy aircraft entered our kitchens and quietly conquered the planet. So, what is happening inside that humming box in your kitchen? In a microwave oven, an electron tube called a magnetron converts electrical energy into microwave radiation. These waves bounce around the metal cavity and are absorbed by the water molecules and to some extent fats and sugars inside your food. These waves flip those molecules back and forth billions of times per second. The rotation creates friction, and friction becomes heat. That is why foods with more water heat faster. Food heats rapidly because the energy goes straight into the molecules, not to the surrounding air or a hot metal coil. That is why reheating yesterday's rice in a microwave takes a minute instead of 10. If you want to know more about the science of microwave cooking, you can check out this video I had done a long time ago. Microwaves attract more pseudoscience than any other kitchen appliance. People still worry, does microwave radiation make my food radioactive or dangerous? Does it cause cancer? The answer, according to health and safety agencies, is a big no. Microwaves are a safe part of the electromagnetic spectrum, similar to radio waves. They don't break DNA, they don't make food radioactive, and they don't summon ghosts no matter what WhatsApp forwards say. Microwaves are non-ionizing radiation, meaning they don't have enough energy to alter atoms the way X-rays or nuclear radiation do, so it cannot cause cancer. The metal walls and door mesh are designed to keep the waves inside, and once you switch off the oven, the waves vanish instantly. Think of it like a flashlight, since both visible light and microwaves are part of the same spectrum. Once you switch off the flashlight, the light disappears. Microwaves do exactly the same thing. The real twist: for small meals, microwaves are safer and cleaner than open flame cooking. No smoke, fewer carcinogens, less energy wasted. Wait, the myths do not end there. Many claim that microwaves destroys nutrients in the food. In reality, all cooking destroys some nutrients. And because microwaving is usually faster and uses less water, it can actually preserve more vitamins than boiling or over frying. Another claim is that microwaves make food radioactive. Well, only radioactive materials make things radioactive. So unless you're cooking your biryani with uranium, you don't have anything to worry. The microwave reshaped modern life in ways we barely notice. It changed how people work. Office lunches became possible without a full kitchen. It changed how food companies operate. Ready-to-eat meals, instant noodles, microwavable popcorn, microwavable food packets, and freezer ales all exist because of this one appliance. It changed energy use. Heating a mug of water in a microwave uses far less power than boiling it on a stove. It changed kitchen safety. No flames, no coils, fewer burns. Most of it all, it normalized the idea that heating food is a trivial one-button task instead of a mini project. Convenience became a technology and the microwave became its most successful ambassador. So the next time you reheat tea or pop popcorn, remember it all started with war radars, a self-taught engineer, and a melting chocolate bar that nobody else would have noticed. One curious question turned battlefield technology into a kitchen convenience. The microwave oven is proof that some of humanity's most important inventions come from accidents, curiosity, and someone who refuses to ignore a weird observation. One melted chocolate bar in a radar lab opened the door to an entirely new way of cooking and quietly changed how the world eats. In the next episode of this series, we will explore another quiet revolution in your kitchen, the refrigerator. Subscribe, share this story with someone who loves science, and stay curious.